Today we would do something which is called anti-differentiation, and there is two things. We also say it not only anti-differentiation. Let me have us a little, and here I change the font size. So anti-differentiation. What is differentiation? We did it last time also. Do you have an idea what is a differentiation?
Differentiation is the gradient at a certain point.
Yeah, gradient. That's correct. It is dy upon dx. Yeah, so today we would do anti-differentiation. We know what is a differentiation. Differentiation is dy upon dx, which is also a gradient. And in another way, if you see what it is, we are looking at a very small part and looking at its gradient. For example, let me draw it something like this, and I take another color and I say, okay, this is a small part, and we say dy is, and if you remember, it is also say limit h tend to 0, or I can say just like another way, delta y over delta x. Do you remember that?
Yep.
So it means it is a very small chunk, a very small thing. So what you would think of the anti-differentiation, it would be opposite of the differentiation. In some of the top books, it is also called, so I write it another. It is also called integration. In English, what is meant by integration? Do you know integration word?
Not really.
So you say, oh, the people should integrate together. Uh, have you heard this sentence sometimes?
No.
Okay. And integrate means join together. So
Okay.
integrate means, in the English, integrate means join together. Integrate, join.
Yep.
Yeah.
Yep.
And also you can make a connect with differentiate. Differentiate means as you differentiate means you make the difference, and the difference, and here the integrate means you join together, right?
Mm-hmm.
So first of all we understand, and therefore it is called anti-differentiation, and uh, it is also called integration, right?
Yep.
Okay. Um, let's see. I would ask you a few things and then I would say. So I would correlate differentiation and integration so that we are somewhat more comfortable. Let's say we have a curve like this, not a linear curve, but something like a non-linear curve, right? And if we have to find a differentiation at at a point, we actually have a tangent, and then we know this, and we then at a very small portion at this point P, if it is this point is P, we make a small delta x, delta y upon delta x and find the integration. Do you differentiation? You have
Yep.
that knowledge. Now the integration is something else. But let's say we take two portions for the integration. And normally, let's say this is a point P and we have another point A. And this function is fx. The curve has a function of fx, right?
Yep.
So if we want to integrate this thing, so what we are saying, we would have all the area under the curve under these 2 points calculated. So we are integrating. What does it mean? If I make something like another thing, the same curve, and try to, let me have the curve something like same. So what we would be doing, we say we would make a very small, like a rectangle. We would have these rectangles till this point P, and then we would add them together. And we would know the area of this from the point A till P. Does it make some sense to you or no?
Yep.
So in differentiation, we were just saying the gradient, while in the integration, we are integrating these small strips together, which I
Mm-hmm.
have made, right? And writing it in a mathematical form, this thing would be written like this. For the integration, we put some a curve like a not like an S, but somewhat, and then we say, okay, this is fx. What is fx? Fx means our this function which is, and then we say, okay, we multiply it with dx, and we say from a to p. You would understand this what I say. What is fx? If you see there is a function, what is meant by fx? For example,
Fx is y.
yeah, why? Very nice. Right? Now you understand interesting thing. What is dx? Dx is a very small x.
X.
So what, as I have made this strips, actually dx is this strip which I am making in blue. And what is this? This is your fx. Does it make sense to you?
Yep.
What is this thing actually? If you are multiplying fx with the dx, so what are you getting actually?
Um, the gradient line.
No, 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 no. If I just make another thing and I ask you, let's say I have something like this, which is a rectangle, and the height of the rectangle is fx,
The
and
area.
very nice, very nice. It's an area. So actually, if you see what we are doing it now, this makes sense. Fx and the dx, and we are saying move this thing from A till P point. So actually, for this example, which I am doing, I am just writing and showing it in blue. We are finding this area. Does this make sense to you how we are finding this area under the curve from this point A till P?
Yep.
So it can be any point. For example, I say, let's say, we do it very interestingly, and how to do that is another thing. So linear, this is a linear equation, y is equal to x. You know y is equal to x?
Yep.
So this is passing through origin, c is 0. And this is 0, and this is 5, right? We
Mhm.
want to know the area of this curve. So we would take this example in our next topics also. But at the moment, let's say if you want to find this area, do you know what is this area? If I make a rectangle, triangle with the base 5, and what is the height here? Because y is equal to x?
Uh, 5.
Yeah, 5. And if you do it by integration, not by integration, rather by area of a triangle. So do you know what is the area of a triangle?
Base times height divided by 2.
Yeah, so base is here 5, and this is, so we would have 25 divided by 2, which becomes 12.5. Does it make sense to you?
Yep.
This is a simple thing. Um, Area of a triangle is easy, but what if this curve is not like this? Rather, it has a complex function like y is equal to x cubed plus 2x square minus 9x plus 14. Now this becomes very complex. It is no more a triangle, right?
Yep.
So integration help us. I would anti-differentiation. If I say integration, you understand I am referring to anti-differentiation, right?
Yep.
So it's the same name for. Let's do this question with the integration also. So I would say integration in this would be from what, lower limit would be 0 and the upper limit would be 5. Why? Because we are doing like I showed here, we from A to P. In our this example, O is A and P is 5. Do you see this?
Yep.
And what is fx in this case?
Uh,
The
F.
function. What is
Yep.
the function here? It is a
Uh, Linear.
yeah. What is that function?
Uh, y. The domain would be 0 to 5.
Yeah, that is. But what is the function? Because the
Y
function,
equals x.
yeah, y is equal to x. But normally, if you see, again, perhaps it would be good to say this thing. Once you say y is equal to x, it is also something like we say y is equal to what is the function of x. So this is actually what, once we say the function is there is a input and there is a output. So for example, in this case, In this case, X is the input and the Y is the output. Do you understand this or no?
Yep.
Because if you remember in your lower classes, you would have done like this. You put the value of X and you say what is the value of Y. And in this function, if I say 0, 1, minus 1, 2, 2, so minus 2. So because the function is Y is equal to X, so this is 0, 1, 2, minus 1, minus 2. Does it make sense to you?
Mm-hmm.
So actually, the function here is just X, because that means whatsoever is X, Y is the same. Does it make sense to you or no?
Yep.
For example, now let me ask, if it's a complex function like this, so the function would be what? The right side of the equal sign or the left hand of the equal sign, or both the right and left side of this equal sign where I am putting my mouse?
Right hand of the
Only, yeah.
equal sign.
Yeah, right. So here. So we have this, and now what I should put here as we did earlier? What should I write more? Multiply by what thing?
Uh, t- dx.
Very nice. Multiply by dx. So we have this equation, right?
Yep.
Okay. So if you remember um, entire differentiation, we say they are opposite to each other, right?
Mm-hmm.
So if we have x square, y is equal to x square, what is dy upon dx?
2x.
Very nice. So it's 2x, right?
Yep.
So if I see here, um, it means if I am doing an anti-differentiation of x, so it means can I write like this one? This also means 1 over 2 dy upon dx is equal to x. Yeah?
Yep.
Okay, let's look at here. Um, let's look at here, and we would be able to do like this is equal to, perhaps you have done this, so it would say x square over 2. Do you know that the entire anti-differentiation of x dx is x square over 2?
Uh,
No. Okay.
yep.
Even if you do not know, we would do as per the equation sometimes. But
Okay.
now this is something which is we know, and then the values is 5 to 0 because we want to find it from 5 to 0. So what we would do, we would put the values. So it means I take another color so that it's differentiated from this blue, yellow, which is. So we would have 5 square over 2 minus 0 square over 2. Do you understand this or no?
Yep.
And what did this means? 25 over 2 minus 0, which comes out to be 12.5. Is it good?
Yep.
And this was the answer which we did here by a simple area of a triangle. You see this? And
Mm-hmm.
the integration has also given us, or the anti-differentiation has also given us the same value. Do you understand?
Yep.
And why this anti-differentiation is more powerful? Because uh, many times we come across non-linear equations which are difficult to otherwise find. Yeah?
Yep.
Okay, that's good. So we say that if a function is, if, so first formula, and perhaps you know this, but I would write it again for anti-differentiation. So it says if y is equal to a over xn, we say this is a function, right?
Mm-hmm.
Or there is another way of doing it. Another way of doing it, we do like that, right? This is a function. Let's say we do it two ways. Dy upon. First, I would do like this and try to explain it in another way. Is equal to a raised to the power xn. Yes?
Yep.
It says then y. Why? Because this is a differentiation which we are seeing here, right? If we
Mm-hmm.
do the anti-differentiation of this thing, it would give you the y. It means, this means, this implies. So what are we saying doing? We are applying anti-differentiation to this thing, dy
Yep.
upon dx. And that would be equal to ax n plus 1 over n plus 1 plus c. Do you understand this or no?
Yep.
I would try to explain it in another fashion also. If you see, um, let's say this is dy upon dx is equal to x square, just x square, right? We are
Mm-hmm.
making it not very difficult. A is 1 and what would be y then, looking at this?
Uh, it'll be uh x to the power of 3 divided by 3 plus c.
Yeah, c is a constant. So it is a constant, it could be any number. We would see what is meant by this. Now we just see that this is the equation. If I differentiate this equation, and you know differentiation, what would be dy upon dx if we have this equation?
Uh, it'll be x squared.
X squared. Yeah, it is a x squared, but it would be, for example, 3x squared over 3, right?
Yep.
And this 3 and then differentiation of a constant. What is the differentiation of a constant?
0.
0. So this becomes x squared, right?
Yep.
So this is dy. Now we see something very interesting. What we had this thing as, so if you see this and this are reverse processes. You integrated or took anti-differentiation of x square, it was x cube over 3 oh, plus
Mm-hmm.
c. Once you took the differentiation of the function, you put this. You got this. Do you understand this or no?
Yep.
So they are reverse, like a division and multiplication is a reverse process. So it means anti-differentiation and differentiation are opposite process to each other. Does it make sense to you or no?
Yep.
Just we would do very quickly something. For example, if so, it's something we can say like this. Examples. I do few examples with you, but you should understand one thing that you have if a is equal to xn, yeah. So
Yep.
its integration or entire differentiation would be a xn plus 1 over n plus 1 plus c, and I write here entire differentiation. Do you see this? Just remember it, or yeah, we would
Yep.
do few questions just by doing this. If we have y um, is equal to x cube, and we want to integrate it. Integrate means taking what would be this, and
It
and
would be x to the power of 4
yeah,
over 4
yeah,
plus c.
very nice, right?
Yep.
So actually, once you have, so what we write it like this. So this is y is equal to, I just want to, so it's correct. Normally, what we write it like this, we say, in this case, this becomes integration, which is this function y dx. Do you understand why I am writing? And this is actually equal to x cube into dx. Do you understand this, what I have done? Because
Yep.
we wanted to integrate. Integrate means anti-differentiate y, which function was x cubed. So we write it like this or like this, and then we get this function. Does it
Mm-hmm.
make sense, or should I repeat it?
It makes sense.
Okay, let's say we have another function, another example, which is a little longer. Y is equal to 4x cubed plus 12x square minus 6x, right? And we want to find its entire differentiation. So what is we do? We say write like this, y dx. Do you understand what we are doing? We are just writing it in a integration manner or anti-differentiation manner, right?
Yep.
So what should we do here? What should I write? 4x cubed plus 12x square minus 6x and then bracket close dx. Do you understand this?
Yep.
Okay. And as we know of many formulas in math, we can open this bracket and then we will have their individual integration. So this becomes this and this becomes 12x squared dx. Then we have this, which is our integration or anti-differentiation of minus 6x dx. Is it good?
Yep.
Any question to this?
Not really.
Okay, hopefully I'm not making you confused by sometimes saying integration instead of anti-differentiation.
I understand it.
Okay, good. And there was something which we have seen that in that is also in differentiation. If there is a constant, you can take it out from the differentiation sign. You remember?
Yep.
So that is also valid here. So we would take this out 4 and say x cubed dx plus we would take this 12 out and we would say x squared dx and we would take my 6 out and say x dx. All good?
Yep.
Okay, I just changed these so that they they look like x. Okay, can you help me to solve this now? You remember the formula or should I write it again?
I remember the formula.
Okay,
So it'll be 4x to the power of 4 over 4.
good. And plus c1, let's say.
Yep.
I would say it all, but at the moment, let's take it as that this integration has given us this answer, right?
Yep.
Then
Plus 12x to the power of 3 divided by 3
plus c2,
plus 2.
c2, because we are saying it's
Yep.
another constant. Because this integration will give you some constant, right? Because that's a part of a, and then
And then minus 6x to the power of 2 over 2
plus we say it gives
plus
us
c.
another constant.
Yep.
So actually, what we would do now, we would just have the similar terms together. So this 4 in the numerator and this get cancelled. 3 times 1 is 3, 3 times 4, 2 times 1, 2, 3. Good.
Yep.
So this becomes x4 and we are taking the similar terms and but there is no similar term with x4, so we take the next 4x3 minus 3x square plus c1 plus c2 plus c3. Does it make sense to you now?
Yep.
And what is this actually? This is actually constant plus constant give you a constant. And therefore we need not to write the constant with every integration. We would just say x4 plus 4x cubed minus 3x square plus c. Does it make sense to you? And
Yep.
this is our y dx. So integration of the function which was y is equal to something like that,
Mm-hmm.
right?
Yep.
Sometimes because in the book it is given a little confusing, so I would take it in that form. Let's look at the example and example 1. Yeah. And I take just one. Yeah, yeah. Rather, I will do example 2, right?
Mm-hmm.
Example 2, which is there in your book. So, example 2. Let's write it what it is. And should I write it in red maybe? So, it says dy upon dx is equal to 5 minus 9x square. Yeah.
Yep.
And it says find y in terms. So, first part is find y in terms of x. Do you understand the question in
Yep.
terms of x? Right.
So anti-differentiate that.
Yeah, but we would do in a manner that you would understand. So if I take this d right, let's write it again. Dy upon dx is equal to 5 minus 9x squared. Normally we do that. We say,
Mhm.
okay, this is dy, dy. I would just move instead of there down. So we say dy is equal to 5 minus 9x squared times dx. So we
Yep.
just took this dx to the other side and it would be multiplied to everything. Do you understand that?
Yep.
And then we say, okay, I would do it here. Let's entire differentiate. As I said, differentiation and entire differentiation are opposite. So what would be they would, d and this integration sign would cancel each other. So we would just be left with y.
Yep.
Do you understand this or no?
Mhm. Yep.
And this means this becomes, now this question become, and again, we can open the bracket. So it becomes 5 dx minus 9x square dx.
Yep.
All good?
Mhm.
Can you solve this question for me, please?
Y equals 5x.
Yeah. So it becomes, because 5 we can take outside, I just do it a little more. And again,
Uh,
this integration sign and this differentiation sign, they would just cancel each other.
yep.
As so we are left with only 5x. And then here,
Uh, do we need to simplify it first?
which one? It's
For
9x square. So you can
yep.
just take 9 out
Yep. Take 9 out and then
because now,
x
yeah,
uh cubed
x cube,
divided by 3.
yeah, and plus c. Now we are not writing a individual C1, C2, rather we are just writing a big C because we consider that the both constant from these two integrations, which this one and this one are added in a bigger constant, right?
Yep.
And again, we would do the same. So 3 ones and 3. So minus 5x minus 3x cubed plus c. So this is your y. Do you see this?
Mhm.
Any question to this?
No.
So this is our first. Now the second part was, and I take another color, maybe yellow. It says find y when x is minus 1. Can you find that?
Find y. You substitute in x,
Yeah,
so
yeah,
5 minus 3
yeah.
plus
Can you
c.
solve it? Okay, there is a problem.
We don't have c.
Yeah, we don't have C. I would help you with this. But in the question, it is given. When given, so I say given. This was given in the question. When x is equal to 1, y is equal to 10. This will help us to find C.
Yep.
So what it says, so we would put these values in the above equation. Can you help me to write the equation then now with the numbers?
Yep.
Yep.
Uh, so we first do this. We use a we use a given x1 first
Yeah,
to calculate c.
yeah. So,
So we put in x equals 1.
yeah.
So it'll be 5 minus 3
5
plus
minus 3
plus c,
plus c is equal to
10.
10, right? So what
So c equals to 8.
c is equal to 8.
Not 8.
Yeah, c is equal to 8. Why?
Yeah.
10 is equal to 5 minus 2 plus c. This implies c is equal to 10 minus 2, and this means it is equal to 8, right? So
Yep.
we got it. So our equation becomes y is equal to 5x minus x 3x cubed plus 8. Yeah, why?
Yep.
Just so if you compare them, 5x minus 3x cubed. So now we come to the other part. What is y when x is equal to minus 1? You just put it there. Y is equal to, this implies y is equal to 5 times minus 1 minus 3 into minus 1 cube plus 8. All good? So it means y is equal to 6. If you solve it, it becomes 6. Any question till this? So it means when x is equal to minus 1, y is equal to 6. All good?
Mm-hmm.
Okay. Um, let's come to your exercise 7a. Let me know any question which we do together, because then we would move to the exercise 7b.
Uh,
Maybe one or two questions if you want. We can do it at exercise 7a, or do you want that I jump to exercise 7b?
I feel like 7A is simple enough. We can go to 7B.
Very nice, very nice. That's good. Okay. Um, this is something, let's correlate what we have learned today. Um, differentiation is like you told me. What is differentiation? It is gradient. Is it also a rate? We covered it last time. Rate of change. Is it also differentiation?
Uh, yep.
How?
Uh, since
Do
the
you know this? Or if you don't know, I would explain it.
since the rate of change is how much it changes in one term of run, and gradient is rise over
You're
run.
right. Very nice. Very nice. So differentiation is actually the rate of change. And what is integration? We said it is integrating. So if I see this thing like, so this is some differentiation is giving you something like where I am. And if you integrate, you are finding total area. Yeah.
Yep.
So what does this mean? So it means if it is, for example, it can give you the total profit maybe, it can be give you the total area maybe, it can be give you the total volume maybe, if depending upon what is this function which we have effect. Uh, Again, I just repeat and we do one question. So we said the differentiation give us the rate of change, while the integration or anti-differentiation add all of that together. So we understand that. If it is something like uh, a rate of change, again, if I see this is and from here to here, and we take different steps and add them as I explained at the start of today's lecture. So these strips are not actually, it's not just because, yeah. So these strips. So what are we seeing? We are actually, it was, we are integrating. And this area will, if this is the rate at which the things are sold maybe for a month, this all area will give you the amount which is earned during this. Do you understand this or no?
Yep.
Uh, I give you a very small example, a practical example. What is speed? Kilometer per hour, right?
Yep.
So if I put, and I would just take your help to explain this. So speed is actually distance over
Uh, distance over time.
distance over time. For example, if I say somebody is, this is a speed and this is time, right? We are doing this. And someone is going like this. Can you tell me, um, rather, let me start from here. Someone goes like this, then goes like. Can you tell me what's happening to this journey till this point? let's say this is 10. Let's make it a 60, and this is for maybe 20. Can you explain what is happening to this?
Uh,
So maybe somebody has a car, at this is our time. So at 0 he starts the journey, right? This is maybe 60. Can you tell me what's happening? Any
uh,
idea?
it's
Hmm?
it's it's increasing and then it's not changing.
Yeah, so it means he started the journey in 20, if it is seconds, or I don't know. Yeah, we say seconds. So what did he did? And this is, or yeah, and this is a meters per second. So what he does, and this is a straight line. So not very well. So I would just rub it and again. So what happened is here, the person has switched the car,
Yep.
has accelerated to a speed of 60 meter per second in 20 seconds. Does it make sense to you? No.
Yep.
So he started here where I'm putting 0. It was not moving. And what happened from this point till this point?
It didn't increase in speed, but it didn't decrease.
So it means now he is driving the car with a constant speed of 60 meter per second. Maybe
Yep.
it's a road speed limit. So he started, do you see this or no?
Mm-hmm.
Now, if you take a area under this, what this area under this curve will give you? Any idea?
Uh, it'll, it will give. Not sure.
It, let's see that, what this area gives, right?
Yep.
Yeah. Let me ask you, you know that the integration would give us this area, right?
Hmm.
Okay. But let me first ask you, if I just make it like this. This is 20 and this is 60, right? This is a
Mm-hmm.
right angle triangle. So if I say half times base times height, right?
Yep.
So what is this thing actually equal to? This comes out to be,
600
yeah, this comes out to be 600. And what is 600 now? We would just see that. If you see, what was this 20 second? So I
Yep.
now write also the units, 20 second. And what is next? 60 meters second, right?
Yep.
And this second is in the denominator, and so this cancels. And you have what is the unit of 600?
Meters.
Very nice. What does it mean? It means he has covered in 20 seconds a distance of,
600 meters.
yeah. And if we find this area, which is here, which I am making it from 20 to 60, so it's a rectangle maybe.
Yep.
The
So it's
rectangle
60
40,
times 40,
yeah, 60 times 40 is
2,400.
2,400 meters. So in this, how much total he has covered? 3,000 meters. Very interesting. These were very straightforward. And if we do it with the entire differentiation now, so there are two parts. We will have to find the function of this line and the function of this line. Yeah. I see this function is the second function is easy. And because we know that, how much was the second function you found out? That was 2400 here. Yeah.
Yep.
So we just do with the integration the second part. If you would like, I would do the first part also, the second part of the graph, right? So second part says, what is y is equal to? Function. So y is equal to 60 because it remains there.
Mm-hmm.
So we have to integrate 60 dx. And what is the values from 20 to 60? Do you see this or no?
Yep.
If you don't, let me know. So if we take 60 out, 20 to 60, What is the integration or anti-differentiation of dx? Hello?
Uh, the entire differentiation of 6c is 0.
No, 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 no. It's
Uh,
outside. The
oh, so
constant is out.
it's
You don't do
so
anything.
it's so it's 60x,
60x. And you have a upper limit and lower limit of?
60 and 20.
So what would it would be? 60 times, or let me put a dot instead because sometimes you person may get confused. Is it x or and 60 minus 20? So
Yep.
what is the answer?
Uh, 60 times 40 equals 2,400.
Oh, 2400. And that was the answer which we got here also. That's the same meters. Do you see this?
Yep.
So actually, by doing the integration of the rate of change, what is distance? Speed, distance over time. It's a rate of change. And by integrating, we have found the distance. Does it make sense to you?
Yep.
And even if we do for this, and we have done integration for some this type of function, so you would see that this will give you a 600 meters. So that is your assignment. You would do it afterwards, right?
Yep.
Okay, so we are now clear about it. So let's do one question from exercise 7b, which would help us to understand this. Which one question you do want to do? You have to do the example 3 yourself. I would not be going through this example, or if you want, I can go through this example.
It's fine.
Hmm?
It's fine. I think I understand it.
So you are good with example 3. I don't
Yep.
need to.